Hey guys, welcome to the Dash DAQ webinar. I'm excited to talk to you guys today. Hope you guys can all hear me. Can you guys all hear me? Maybe just type something in the chat. Okay. Yes? Okay, awesome. Thank you guys, appreciate it. My name is Matthew Chan and I'm an engineering intern here at Plotly. Over my time here at Plotly, I worked on building Dash DAQ demo applications, like the application I built with Sparky. There's a whole bunch of other applications that were built. You guys can check out at dashdac.io. But today, we're going to be talking about Sparky. I'm going to give you guys a brief little overview of what we'll be talking about today. So for those of you who aren't too familiar with Dash, I'm just going to talk a little bit about Dash, and I'll talk about Dash DAQ, and then who Dash DAQ is for, and then I'll show you guys Sparky and me controlling him with the user interface I created. Then after that, I'm going to go over some code blurbs with you guys to show you how I was able to connect control Sparky here with my laptop through Python. And also the reverse, controlling, sending data from Sparky here to my laptop in Python through Dash DAQ. So I'll start off with just talking about what Dash is. So Dash is an open source product by Plotly. It's a framework built on top of Flask, Plotly, JS, and React. But the beautiful thing about it is it allows you to make interactive graphical user interfaces without having to deal with any JavaScript or any of the funky stuff. It's all done in purely just Python, which is just amazing. And since it's also built on top of Plotly, you easily have functionality with your graphs and whatnot, with your data sets that you want to implement. And since it's also built on top of Flask, you can easily just upload your application to a deployment server like Heroku and share your app with your colleagues, your friends, whoever it might be. So this is what Dash is, a way for you to make graphical user interfaces with Python. So now, what is Dash DAQ? So Dash DAQ is a package of components made to be used with Dash. So I'm going to show you guys some of the components so you can understand what I mean by this. So I'm going to share my screen here. Dash DAQ components. So cool. Actually, sorry, just 1 second here, guys. I'm just going to share this screen here. All right, there we go. So hope you guys can see me. I'm just going to move this. Okay, awesome. Got my screen there. So this is you guys can check out the components here at dashdaq.netlify.com. And this is what Dash DAQ is. So Dash DAQ comes with a whole bunch of components you can use with Dash, the open source framework. And the goal of this is to allow engineers and scientists to have like an easier way to make your data acquisition user interfaces. And I know some people struggle with like NI using National Instrument products or whatever. So this gives you the freedom to truly just create your own. So instead of having to program all this crazy JavaScript, you can easily just take a component like the gauge here and just throw it into some Pythonic HTML and CSS and have it working easily. And with Dash, it allows you to control what happens with these components with our callback system, which I'll describe to you guys later on in this lecture. So hope you guys can see this. I'm just gonna zoom in a bit so you guys can see better. So here are some of the components. I'll show you guys Boolean switches. We play with these. Power button. We got some stop button here. All kinds of stuff. A color picker. And you guys can see how everything is interacting with one another. So it's pretty cool. I recommend you guys go and just check it out. And just to give you guys some context on how you actually use these components, because that might be a little bit confusing. So it's pretty simple. You find the component that you want. So for example, this Boolean switch. And you just grab this code here. So you see DAQ Boolean switch here. And all you have to do is just throw that into your app layout and it's there. It's that simple. And you just use HTML and CSS to modify the positioning of where you want it on the screen. And then you can also add some props, so properties that allow you to do different things. So maybe we want the label to be on top or on the bottom of our component. We'll add in a prop like label position just into here and specify where we want that label to be. So it really makes making a user interface quite easy. So you're probably wondering, how do you actually connect your device, your instrument, with Dash? So this is best described with the diagram actually on the main website, on dash-daq.io. I'll show you guys this right here. So this is the main page, dash-daq.io, if you guys want to check that out. Dash DAQ is $840 per developer for 1 year. So that's how much it costs. As I showed you guys, here's some components. So here is kind of like here's a little like graph to show you how everything connects together. So you'll have your scientific instrument, your test bench, your robot, your servo, whatever it is, and you'll be wanting to connect that to your laptop. So in order to read and write that data, we do that through serial communication. And what that is through a USB, GPIB to USB, RS-232, and the list goes on. There's quite a few things you can do. So now to actually use Python to read and write that data, generally the manufacturer will have a Python driver you can use. So for example, National Instruments has the NI-DAQ MX Python driver you can use with Dash to control their products. But sometimes you also might want to just manipulate the serial port yourself. And in this case, I use a library called PySerial, which is a Python library that allows you to manipulate the serial port. So that allows me to read, write, close, and flush the serial port to send data and receive data between these two devices, so Sparky and my laptop. So once you have your drivers and you got your instrument connected, this is where Dash comes into play. So you want to make an easy, simple graphical user interface for whatever product it is that you want to be interacting with, right? And the best way to do this is by creating a user interface instead of continuously going to Python and sending commands to do whatever it is you want. So Dash allows you to make that beautiful interface while also allowing you to control and read and write data and those commands on the back end. So Dash DAQ gives you those 16 components to easily create your graphical user interface. With just Dash, you don't have these components, so it's kind of hard. It's much harder. So that's where Dash DAQ comes into play. We all know that making a DAQ interface can be a pain, or using Dash data acquisition products can sometimes be a pain in the butt. So this is the whole point of this product. So now that I've told you guys what Dash DAQ is and what Dash is, I can get to the awesome part and show you Sparky. So I'm gonna close this. Hopefully you guys can see Sparky. Cool. Okay. So I'm gonna run my application right now. I think it's probably best if I just screen share. Screen share. Hopefully you guys can see. So this is a user interface that I built with Dash DAQ. So this is a color picker component, a joystick, a knob, and you can just see there's a whole bunch of stuff here. This is a plotly graph you can implement quite easily. Show you guys me interacting with it. So can you guys, okay, cool. You guys can see Sparky and my screen well. So, yep, okay, awesome. So right now, as you can see, I'm just playing with the color picker and you can see actually the LED of Sparky is changing colors, which is pretty cool. So want it to be green. And you can also see I have it interacting here with the banner too, changing the color of that. It's pretty awesome. So that's pretty neat. We can get Sparky to move around. So we're moving Sparky forwards and backwards with the joystick component. As well, we can get Sparky move his head. So Sparky's head's on a servo. We're just moving that guy around right now. Let's have Sparky look at you guys. Another cool thing too is because there's a piezoelectric in Sparky. If you don't know what that is, you send some voltages to it and it makes some frequencies. But anyways, we peg those frequencies to the scale of some musical notes. So I'm going to show you guys right now. If you're wearing headphones, this might be kind of loud, just a heads up. So I'm going to make Sparky make a noise, make the same noise as a note, the F note. So that's pretty cool, right? Some other things too. So Sparky has some grippers here. We can also control that. So we're open the grippers right now. Hopefully you guys can see that. We're gonna close these grippers on this marker here. I'll face Sparky towards you guys so you can actually see him better. There we go. So that's kind of cool too. So I'm gonna get rid of that marker now. This is my favorite part though. This is what actually took me some time. So here's one component here. Sparky is an ultrasonic sensor. As you guys can see, that's his head. And what this does is it detects how far an object is in front of him. Yeah, so I'm not gonna go too much into detail, but that's all you really need to know. So say I take this marker, we put it in front of Sparky's ultrasonic sensor. We can actually see how far that object is directly on our user interface. So if something isn't, if there's an error with the ultrasonic sensor, it'll just send an error like this. So no objects detected there. So yeah, it's pretty neat. This is actual data from the ultrasonic sensor. And I think the beautiful part, something I thought would have been was really cool was since Sparky's head rotate in 180-degree motion, I was thinking, why not make Sparky detect or capture data at every 1/10 of a degree and then graph that on a plotly chart. So I'll show you guys here. I'm gonna click the sweep button. I'm just gonna zoom in a bit more so you guys can see a bit better. So I click sweep, and you can see Sparky's head is moving. And from the data that it captured, it took it, compiled it, the 18 data points, and sent it to Python to my computer and plotted that on a plotly chart. So I'm going to be showing you guys how I did that, but I'm just going to show you guys again just because it's super cool. So we'll put this here, and you should see the points concentrated mostly in the 90-degree range. Yeah, so you guys can see that. If you go over the cursor, you can see how far the object is, the angle. It's kind of hard to see so close. So that's pretty neat as well. And now I'm going to just talk a little bit about, because I'm going to be transitioning into how we're actually sending data to Sparky. So if you guys can see here, you see this right here. So it's command string, right? We have this funky looking string. So when I do a command on Sparky, this will change that string. So something like clicking the color picker. So I don't know if you guys saw, let's do it again so you guys can see. I click on things, you can see the callbacks, you can see if there's something going on behind the scenes, and the string is changing. So what's happening is, in order to communicate with Sparky from my laptop, since it's communicating through serial communications, and Sparky is based on an Arduino microcontroller. It's continuously reading data that's being sent to it, reading just strings of ASCII and ASCII. So what I do is I create my own string here with this. I created my own string here, sorry, with this. Go here with this less than sign and this greater than sign. And you're probably thinking, like, why is that there? So the reason for that is, since it's Sparky is continuously receiving data, how does Sparky know what's actually important? So when this string gets sent to Sparky, it'll be reading these characters. So like this is one character, for example, it'll be reading the characters. And once it sees this less than sign, it'll be like, okay, it's time to read this data. So when it sees this, it'll start actually taking in this data and seeing it as important. And when it finally reaches this greater than sign, it'll stop reading the data. So this is how Sparky is able to understand what commands I'm sending to him. So I'm gonna be sharing some code blurbs with you guys so you can understand this a lot better. But I hope you kind of got a little gist of what's going on. So yeah, there's that. It's a Sparky. It's super cool. Make it move around, do a bunch of stuff. And this whole app is interactive, which is really sweet. So I'm gonna go into the code blurbs now. I made a little webinar code blurb for you guys. Hopefully you guys can see this well. This is pretty zoomed in. Just give me a sec. Okay. So significant feedback as a noise, like you're not able to hear it super well. Stephanie Davis. Oh, I hear you twice. Yeah, that's kind of weird. That shouldn't be happening. Let's see if I can mess with anything. Try to just fix that. Let's see. Oh, okay. Well, if other people aren't having troubles with it, maybe it is. Yeah, okay. Okay, cool. You guys hear me correctly. I actually want to ask you, can you guys see this code clearly? Zinghad, Jeremy, yeah? Okay, awesome, guys. So I'm just gonna go over like a very basic overview of like how to add components to the Dash layout and also the callback system. So cool. So first off, I'm going to start with adding components to the layout. And this is actually going to be based on my Dash DAQ app. So I'm going to show you the piece that I'm talking about right now. We're going to be looking at this guy right here, color picker component, and we've got an HTML header. So as you guys can see, we have some HTML divs here. Basically just like little boxes that hold all the elements and whatnot. So we have, since it's done in Pythonic HTML and CSS, we can take advantage of HTML. So right here we're adding in a header, LED color, with the ID, LED title, and the ID basically just points to our object. So you'll see more about that when we talk about the callbacks. We have some styling here, so it's a little bit of CSS. Just to line it, position it. And then here, we have our color picker component. Like I showed you guys before, it's literally as simple as just copying and pasting this guy into your layout and then changing the properties that you want. So for this guy, we can change his size with some of the properties. We got some values here, red, green, blue. So the RGB colors, because it's a color picker, right? And also some more styling here to just style our div. So go back, show you guys that. This is the title, the color picker. Now, I hope that makes sense. I know it's quite quick, but hopefully you kind of just got a brief understanding of that. So now what I'm going to talk about is just a simple callback. I'm gonna just zoom out a little bit. All right, cool. So this is a simple callback that changes the color of the banner. Again, I'll show you guys that happening right here. You see the banner, when I click on the color picker, things are changing colors. Super cool. All right, so we have our layout, our HTML div that contains our banner up here. Whole bunch of stuff. The important piece to note is ID is equal to container. This ID points to this HTML div element and all its contents. So what we're doing is, sorry, I'm going to talk about the callback here. We have an input and an output. Hopefully you guys can see that. Actually, oh, yeah, that should be better. You guys can see that in input and output. So like before, I was talking about ID pointing to the component or pointing to the object. So I'm going to scroll up now back to the code blurb before to the color picker component. So you guys can see that ID. So keep this in mind, LED control. Just keep that in your head for a sec. So we go to the color picker and we see ID is equal to LED control. So that's how we point to this object, point to this component. So our input is now the color picker, LED control, and we have a prop here, value. I'm gonna go back again, keep that in your head, value. So this is the property of this component, value, with the RGB colors. So, so what happens now is whenever the color picker's prop value changes, so basically whenever I click on here and the color changes, the value changes, this is gonna fire the callback. So what I mean by fire the callback is everything in this function will be run, and then whatever is returned in this function will then be sent to this output over here. And this output is another element or dash component. And in our case, if we look here at the ID container, this contains the banner. So again, container, ID is equal to container, which has all this stuff in it. And we're returning to it. We're returning the background color. We're returning this dictionary here, sorry, background color key with hex color to the style property just up here. And I hope this is easy for you guys to see. It's quite zoomed in on my screen, but I really hope you guys can see it. So cool. So this is basically the premise of how callbacks work and how you put components in your layout. So now I'm going to start talking about how to send data from Python, from Dash to Sparky here, my Arduino powered, my Arduino microcontrolled C++ little robot guy. So sending data from my laptop to Arduino, cool. So like I said, guys, I used a library called PySerial. So this is a library here. I'm importing serial, which is PySerial. The first step here is to actually open the serial port. So I'm setting the COM port here. I'm opening it. I'm assigning it to this variable SCR. So this is the COM port, COM6. Here is the baud rate, and you'll have to check with your device. I'm just reading the comments. It's not available on GitHub, actually, just because this is the paid project I'm showing you. If you do, like Dash DAQ actually comes with all the code blurbs for all the demo applications we made. So everything fully functioning and working, so you can see it yourself. But unfortunately, this will not be on GitHub. Sorry about that. But I guess like the video is online, so you can just look at the code, and hopefully you can just rewind it. Anyways, though, sorry about that, guys. Okay, so we're gonna set the COM port here. We're gonna open the COM port, right? Open the connection between Sparky and my laptop now. With COM port 6, baud rate 9600, we're simply just flushing the serial port. Maybe there's some stuff in it. I could just do that. It's kind of like a personal preference thing. Okay, so I'm gonna zoom out now. Yeah, okay. So now we gotta determine which button is pressed, right? There's so much happening on here. There's so much happening on this app. right? As you guys can see, a joystick, everything, right? How do we know what was most recently pressed? So for me, I created a system for myself, or I created a system for Dash on my own to figure that out for me. So Python comes with a time library that tells you the time since 1985. And basically, whenever you interact with something, with any component, it'll call this callback here. So I click the stop button. It's gonna now run this callback and return time.time, which is some big number at this moment in time since 1985. And it's gonna return it to an empty HTML div, which is called beep hold, and store it in its property children. So it's gonna store time.time in an empty div, essentially. And this is how we share data between callbacks. So based on which number, based on what you interact with, you're gonna have whatever is most recently interacted with will have the greatest value, the greatest time.time value. So knowing that, we can take all our inputs and call another callback here that will look at all the values that we have stored in those empty divs, then find the greatest one. And based on what the greatest one is, I'm going to send that again to an empty div. And this one's called case hold with property children. So this is going to hold my data case, is what I call it. And what I use my data case for in terms of the Arduino is basically I have a switch statement in Arduino to simplify the code further. And I'll be showing you guys that, so that'll make a bit more sense. So don't worry if you don't understand that part right now. Again, I'm doing the same thing. I have just a bunch of, I call this my command string. So I'm just gonna go back to the main app so you can see what I'm talking about. This is a command string. And each of these callbacks is determining what value is here, what value is this guy, and what value is this guy, and just vice versa, just barrels down. So depending on what I pressed, it'll give me up, left, right, whatever it is, and then return that into an empty div called command string. So now we're gonna go to the master, the central command, where everything is going on. Sorry guys, trackpad, okay. So now that we have our string like assembled, all the data in these empty divs, now that we have all our data in these empty divs, we gotta take all that data and compile it into a string. So you can use something called state to basically grab values from your props, from whatever component you have, and in those props, they'll have your values, and then you can grab those and use those in callbacks. So that is another way to share data between your callbacks. So I have all this data stored, and I'm just gonna make this string here, plug everything, all the stuff into the string, and now I'm gonna encode the string in ASCII, because that's how our Sparky reads data. I'm gonna flush the serial port, and then I'm gonna do something called serial.write send, right? So zoom in, you guys can see that. This is pretty important, serial.write send. Ser is our port that we defined at the start of this code blurb. And then write is using PySerial to write this, to send our string over the serial line. So that's how we're sending the data from our laptop to Sparky. And now we'll look at what's going on the Arduino side in terms of breaking down the string. So this is our Arduino side, and then all this is coded in C++. So I'm not going to go too deep into it. Basically, what's happening here is it's taking that string, like I told you guys before, looking for that less than or greater sign, and then delimiting that string and breaking it apart. So once it breaks down that string, we're just going to parse that data from that string. We're going to assign each of those pieces of that string. So LED, then it'll be a number, the number, the number. We're going to break that all apart and then assign it to some variables. So for example, we have one right here. It's going to Going to find our first piece of data, just a command string, and then store that in message from PC. And then it's just going to keep going down and down, and it splits the data up based on the commas. That's what parsing means. So once we assign our data, we have to now figure out what we want to do with it. So based on the data case, like I told you guys before, data case is when you, data case is a switch statement to figure out what function we want to run. So we're going to take that data case value that we got from my laptop. So laptop data case sends over to Sparky, and then we're going to plug that in to this function here. So we have a switch statement. It's going to look at data case, and let's just say data case is 1. That means case 1 will run, and it'll run this function, update movement free. So now it kind of barrels down even further. So now we're on that function we were just looking at before, update movement free. And this function is now going to take a look at our message from PC variable, which was our command string. So if our command string is stop M, for example, if this meets this condition, then Sparky will stop. So let me show you guys that. Again, if you see this, guys can see the command string down here. If I press here, now we see that this changed to stop. This piece right here, changed to stop. This is the command string. And now it'll evaluate that and then perform whatever specified command. So that's basically how you communicate from your laptop to Sparky, to your instrument. Now I'm going to talk about the ultrasonic sensor, rotating it in 180-degree motion, and then plotting that data. Because what's happening here is actually we're sending data from the Arduino, from the microcontroller here, to the laptop. So first thing to look at is the Arduino sending data to the laptop. So we just have a for loop iterating every 10th degree of Sparky's head movement. And basically, I'm doing the exact same thing I did on the laptop side, creating that string with the less than and greater than sign and all the data in between. And we're doing that in a different way, but from the Arduino. So instead, Sparky's gonna get some data. So every 10th degree, it's gonna get some data, right? So at every 10th degree, we're gonna want to store that data, so we're gonna want to create a string with that data. So my string will look like this. There's gonna be a C, the letter C, the angle that Sparky's at, the letter C, and then there'll be the letter A, the distance that Sparky calculated or recorded is a better word. Then there's gonna be an A. It's gonna look like C, data C, A, data A. And then that data is gonna be sent from Sparky to the laptop. And then again, we just have this, we're just gonna delimit and parse that string down. So that's basically what's happening here. Serial 1.print is Sparky's way to send data, to write data over the serial line. And then now on the Python side, we got destructured the received ASCII data into Python graphable data. So we just have a callback here. I'm just gonna talk about this piece here. This is really the juicy bit. Sorry, I mean this part is the juicy part. So on the laptop side, we're gonna clear the buffer. We're gonna clear the serial port because there's data going through continuously. So we don't want any noise, any garbage data. And now we're gonna read 180 lines because just because this is what works for this is 18 data points. So basically what's gonna happen is Sparky's gonna send this huge array of a bunch of strings with the A's and the data and the C and then more data. So what we need to do is just take that array, break it down into a bunch of strings, and break that data down into a way that the laptop can interpret. So there's kind of a lot going on here, and it'll take me a little while to explain, so I'm just gonna cut to the short and sweet part. So basically, after we break that data down, we're gonna have two lists, one with all the angles that Sparky has from 0 degrees to 180 degrees, and all the distances he recorded, and those pieces of data will be correlated with each other. So at index 0 of the angle array and index 0 of the distance array, those two data points will correlate with each other. And then I'm gonna make a data frame, which I do here with pandas, and then store this data in two columns that I made called angles and distance in that pandas data frame. And now I'm gonna JSONify the data, because that's how Dash deals with data and its callbacks, through JSON. So I'm gonna JSONify that pandas data frame and then send it to another callback. So we're gonna return this data now containing all our angles and our distances, and return it to something called, turn it to an empty div called sweep hold with the props children. And then now I'll show you that next callback where it gets returned. So when that output of that last callback receives data, that output is this input here, then this callback will get fired. So now what's happening here is the data is getting sent to this callback, and it's checking to see if that data is actually exists. And then simply, it's just taking that pandas data frame and creating two lists called theta and distance, or R. And we're just gonna pass these two lists into a plotly graph. So this is the plotly graph here. We have theta equal to theta and R is equal to R. These are gonna be two lists. Theta is gonna be a list of the thetas. R is gonna be a list of all the distance points. And this entire blurb of code will just get returned to a plotly graph, which is sweep graph figure. I know that was a lot to go through, and this was kind of, I talked quite a bit for this, so I hope you guys understood a lot about what I was talking about. Thankfully, you guys can go back and watch this webinar again if you need to. And you guys can reach out to questions to myself if you like as well. On dashdaq.io, like Zing had posted, there's a blog post that goes into depth as well. I want to thank you guys for coming out to this webinar. I really appreciate your time. And again, if you're interested in Dash DAQ, go to dashdaq.io. Check out some of the components for yourself at dash-daq.netlify. And if you like the product, you love it, buy it, and hopefully it's useful for you guys. I'm going to use the last 5 minutes here to answer any questions you guys have. So thank you. I'm going to close that. If nobody has any questions, I'm going to go. Thank you guys so much. Have a good day.